All right, today we'll be finishing section 5.4. Okay, for this next set of problems where it says write the expression as the sine, cosine, or tangent of the angle, that actually matches up with the next set as well, 9, 10, 11. The question you kind of want to ask yourself is, this is probably worth writing down, which formula matches the problem? You know, you're kind of looking for the matching pattern, if you will. Which formula matches the problem? So, for example, I'm going to use alpha and beta instead of using V's, just because U and V kind of look alike, so I think it's best to do that. So these angles are the same, the 12, so I'm going to call this alpha. So right below it, why don't you write this down? Sine, let's call that alpha. And then this other angle is different, so we'll call that beta. Plus, now 12 we already assigned as alpha, so that's cosine alpha and then sine beta. Okay, so which of the formulas matches that pattern of sine times cosine plus cosine times sine? Well, it's this one right here. Okay, so that matches the sine of alpha plus beta. Okay, so this says go ahead and write the expression as the sine, cosine, or tangent of the angle. So I'm just going to go right above here now and say equals sine of, what was alpha and beta? Alpha was 12 and beta was 8. So the sine of 20, they didn't put degrees or radians. I guess we'll just throw degrees on there, but maybe they meant to have it be radians. I'll just assume we're missing the degree symbol here for now. Okay, so the sine of 20 degrees. You don't have to go find it right now because it didn't say find the exact value. It just says write the expression as the sine, cosine, or tangent because we're trying to match up the correct formula. Okay, let's take a look at 7. Again, which one does this match? What pattern? I mean, if you want to write it out again like this, you could, or maybe you get by with just putting alpha above it. Those two angles are the same and call this one beta. We usually put alpha first as the first angle. So which one matches cosine times cosine and then minus? Cosine, cosine, minus right here. So it matches this one. All right, so this is going to be equal to the cosine of alpha plus beta. So cosine of pi over 5 plus pi over 7. Okay, now to get the final answer, they're going to add these just like the 12 plus 8 up here. This one's just going to involve a little more work on our end just to get a common denominator. All right, so 5 and 7, their common multiples 35. So we're going to have to multiply this one by 7 over 7, right? And then this one by 5 over 5. So that gives me cosine of 7 pi over 35. And then this one's going to be 5 pi over 35. Right? Multiplying the top and bottom by 5, top and bottom by 7. Now I have a common denominator. I can add them together. So we get cosine of 12 pi over 35. Okay. All right, take a look at number 8. See if you can match it up and do what we're doing here to just express it as the sine, cosine, or tangent of just one angle. So here's the answer, by the way. Cosine 12 pi over 35. Okay, try it for 8. Okay, here's 8. It matches tangent of alpha plus beta. All right, so then we're going to take the 10 and the 25, add them together, and just express it as tangent 35. All right, now 9, 10, 11 are just going to take it one step further. Now they say to find the exact value, but clearly a formula has been already put into place. So we're kind of working backwards again, and backwards as in comparison to what we did yesterday, right? We had these angles and then we expanded it to get the exact value. Now it's in this form, so we're going backwards. Part of the reason is some of these angles they give us, we can't find the exact value for anyway. So if you look at 10, okay, we can't find these. Actually, 9 is an exception. We could, but not the 5/12. So we could find pi over 6. So here we go. We're going to find the exact value of this expression. Again, this matches up with which one? Sine alpha cosine beta minus cosine alpha sine beta. Matches up with this one. So this matches up with sine of alpha minus beta. Okay, so I'm done with this sheet now. I don't really need it. Let's just apply it now. So what is alpha and beta? So it's this angle minus that angle. So we got sine of 5 pi over 12 minus pi over 6. Okay, so we got to subtract these. So we got to get a common denominator and do that. So I'd multiply this by 2 over 2 right here. And maybe that's enough just to jump to the answer, but just in case you need to see it. That's going to be 5 pi over 12 minus, that's going to be 2 pi over 12. So 5 minus the 2 is 3 pi. I'm showing all the steps. If you kind of can do some of this in your head or reduce it in your head before you even write down 3/12, that's fine because that's pi over 4, right? This is 1/4. Aha, this is how we can find the exact value then, because we know the sine of pi over 4, 45 degrees, is square root of 2 over 2 every time. Draw the reference triangle if you need it, but there's the final answer. Okay? All right, so just kind of pattern recognition, getting comfortable with the formulas. I know yesterday we used it the other way around because this angle was like 15 degrees, so we had to rewrite 15 degrees using common angles. And this is just backwards because that's not a common angle. And now we can find the exact value of that. All right, so let's see if you can try 10 and 11. All right, find the pattern, put it together, and then you'll just have one exact value to find at the end. Pause and try those two. Okay, just notice the difference of directions. Remember up here it says just write it as sine, cosine, or tangent. So you stop after you do that of the angle, and then here it says find the exact value. So you got to finish it. So this one matches up with cosine of alpha plus beta. So that's equal to, when we add them, 300 degrees. And 300 degrees has a nice reference angle for us, and we can find that. Okay, so the negative didn't come into play. Positive 1/2. Here's 11. This matched up with tangent of alpha minus beta. So when we do 230 minus 185, we get 45 degrees. And we can find tangent of 45. It's 1 over 1. Okay. All right, let's look at this last set of problems. Once you write down the success criteria here at the top. I'm going to pause the video in a moment too, so you want to pause at home. Draw detailed sketches for each angle. Draw detailed sketches for each angle. Gather or find the exact values. Once we have the sketches, we'll be able to do that. And then we'll use the formula to find the final answer. I said find the exact value, but the final answer. Okay. Okay, so basically, if we look at this problem, we're trying to find the exact value sine of u plus v. So let's just go ahead and jot down the formula that we have from our formula sheet. Just following this, u plus v is right here. I'll go ahead and use u and v right now just so we stick with the directions. I don't want to confuse anybody. So sine of u, cosine of angle v, plus cosine u sine of v. Okay. The problem is I don't have those values yet, but we will. I do have some. We have 4/5 in the direction. We have tangent angle v, but that's it. So I need to find these other exact values. All right. So that's why in step 2, I'm saying gather these exact values. Go find them. So let's go ahead and draw these sketches and get them going so we can find all those. All right, let's start with this information right here. I said sine of u is 4/5 and u is greater than pi over 2 and less than pi. They're describing the second quadrant, right? Greater than 90, less than 180 if you want to put it in degrees. So let's go ahead and draw a sketch for that. So angle u is coming over here. I'm going to label it u so we know, keeping track of everything. I'm going to draw a reference triangle. They also told us that sine of u was 4/5. So that means that the y value and the r value are opposite over hypotenuse for our reference angle. So if that's u, I can call this u prime, right? It's a reference angle. All right, and then this is a 3, 4, 5. So this has to be -3 because we're going in the negative x-axis. Okay, so let's go ahead and write down the other exact values. I'm gathering them now. I already have sine of u. I guess if you want to rewrite it, go ahead, but we don't need to. Cosine of angle u is -3/5, and tangent of angle u is -4/3. Okay. All right, so there's u. I'm going to go ahead and just draw a little barrier or wall here for v. Okay, so this is our only problem really doing on this. So your turn to get engaged and try something here. Now they gave us some information on v. Right here, they gave us tangent and they told us where v is located. So why don't you make a sketch of angle v over here in the first quadrant, because that's what it says, 0 to pi over 2, and go ahead and get the other exact values for us. All right, pause to do that. All right, so here we go. Should have got 13 for the hypotenuse. All right, and then we can go ahead and find the sine, 12/13. Cosine angle B is 5/13. Now we have everything we need to finish this off and find the exact value, what they're asking for. Okay, the final exact value for 12. All I'm going to do is use substitution now. Sine of angle U was given as 4/5. Cosine of angle V is over here, 5/13. So we throw that in there. Plus cosine of angle U, -3/5. That's where you got to have these signs right. Times sine of angle V, which was 12/13 on the other sketch. Okay, so that's how we're going to put all that together. Let's multiply it before we add. So for fractions, multiply straight across, top times top, and then the bottom times bottom. So I get 20 up top. This one gives me 65. And this one I get -36 over 65. And then we can add those together because we already got a common denominator. So we get -16 65ths for the answer. Okay. All right, you try 13. The groundwork's already done, so when you do 13, you don't have to start over again. They're still talking about this same setting, okay? So find the right formula, maybe even write it down like I did, and then simplify it. Okay, here's your feedback on 13. There it is. Pause it if you need more time to look it over. All right, so we got 14, a tangent one. Okay, tangent of u plus v. So I'm going to jump right into it and throw tangent of u plus tangent of v on top. So it's going to look like this to begin. Tangent of u from up above was -4/3. Tangent of v was 12/5. And then the other part of the formula says in the denominator, 1 minus the product of those two. So 1 minus the product of those two. All right. So I just multiplied these now to get 48 over 15. Now here's a strategy I think is better than adding these together and subtracting these. If you have a fraction you want to clear, a complex fraction, we multiply by the common denominator or common multiple. So if I multiply all these by 15, it clears the fraction right away. Okay, to this. You can use your calculator to help you with this. All right. So